Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad bin Saiful Haq and my metric number is DF230021. Today I will start with the project background. Our project focus on the Quarters Class D development project, specifically covering the substructure and foundation package. For the technical specification, we are utilizing 150mm by 150mm precast RC square pile with a concrete strength of grade G25. The maximum driving depth is set at 10 meter from the existing ground level. To achieve this depth, we are implementing a two-tier pile splicing system which consists of a 6 meter initial pipe joined with a 4 meter extension pile. For the foundation layout, we will be using 3 piles of peel caps type 1 single, P2 double and P3 triple. In total, the project involves 63 structural pipe points, accumulating a total driven depth of 630 meters. Now that we have covered the background, let's move on to the core objective of this project. Moving on to our project objective, our work is structured around 3 main pillars. First, quantity extraction. Our goal is to calculate and extract precise physical quantities for earthwork, concrete, formwork and steel reinforcement directly from the structural blueprints. Second, SMM2 compliance. We ensure that all structure measurement principles are strictly applied in compliance with SMM2 standard protocol, focusing specifically on Section E for piling and Section F for concrete works. And third, bill of quantities (BQ). Ultimately, we aim to produce a standardized BQ that accurately reflects current market rate of fully fulfilled construction industry tendering protocol. To successfully achieve this objective, we have structured our team with clear role and responsibility. Look at our team matrix. Finally, here is our team role matrix showing how our responsibilities are divided to ensure maximum efficiency. First, Siti Aisyah serves as our project director and lead QS, taking charge of overall formatting, final compilation and the architectural alignment audit. Second, Danish Bazil, our QS specialist, handlers to volumetric taking off for build number 2, which include earthwork, pipe cap, concrete and blending. Third, Nur Afrina Zulaika, our second QS specialist, is responsible for the dimension sheet calculation for build number 1, covering the build, driven depth and testing. Fourth, Wan Daniel, our structural detailer, managing the river scheduling for T12 and T10 steel bar, as well as the formwork area calculation for the pipe caps. And lastly, Nur Aisyah, our estimator and BQ controller, who is in charge of JKR rate, sourcing, pushing and populating the BQ, and final summary verification. With this strategy division of level, we are confident in the delivering and accurate the high quality output for this project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afrina Zulaika binti Azman and my matric number is DF230014. For my part, I will explain the measurement methodology for substructure, piling and parquet work, strictly structured according to the standard method of measurement or SMM2 for Section E. So, there is absolute transparency, traceability and compliance with industrial standard. Our measurement and bill of quantity or BQ preparation follows a structural chronological process of workflow. So for the first stage is the study of drawing and technical specification. Before writing a single dimension, we thoroughly examine the file layout plan, concrete grade and structural cross-section. For this project, we establish our core engineering parameters, which is 150mm by 150mm precast concrete piles of grade G35 distributed across 24 structural nodes 63 structural nodes which encode 3 distinct file types designated as P1, P2, and P3. Note that our ultimate physical count will add 63 action-driven points. And for the stage 2 is quantity taking off stage, which is the dimension are extracted from layout and transferred into the standard dimension chip. We use the traditional QS system of time sync, dimension entry, squaring, and description writing. Piling network are strictly measured via SMM2 section E, while the ancillary piles would fall under SMM section F for concrete work. So for the stage 3 is abstracting and consolidation, which is raw linear area and volumetric figures from the square ring column are cross-checked and aggregated. Similar operations such as grouping reinforcement steel bar by nominal trimester like C12 plus R10 or summing up from work contact areas are consolidated to revise net operational totals, completely eliminating mathematical duplication. And for the stage 4 is billing and price integration. The abstract totals are transcribed into the final BQ using standard industrial nomenclature. Rates are systematically researched and integrated using Public Works Department or JKR database alongside authentic market pricing to deliver a highly realistic tender-ready project estimate. So from the clause SMM2 absorbed into items A and E page 2/P1/1 to ensure streamlined evaluation model for local authority compliance systems. So these are the clause that we use into our project. And for the next, this hydraulic hammer, which is delivery, assembly, disassembling, site clearance for final cleanup and exit logic, and internal handling, cycling cutter ply pitching for item F. So for the next slide is precast file supply and driving. Now I will break down the core piling justification under SMM2 section E. Mobilization clause E3 and E4 state all heavy machinery logistics handling costs are marked as included in our rates. So rather than bill as separated lump sum, material supply from clause E5 state supply is split to reflect manufacturing costs, which is from the table down. There is the initial files item B 63 units with driving shoes at 6 meter length, and the total cost is 45,246 ringgit. For the item C, which is extension piles, 63 units at 4 meters length have total RM 20,335 ringgit. Pulse driving from clause E.5.3b. State driving penetration is being completely separated from supply. We drove 60 piles to a design depth of 10 meters, totally 630 meters of driving at 12.95 per meter, and from there it has total 8,158.50 cents. So we cut and broke back the 63 piles head to ensure a 250 millimeter embedment into the pile cap while exposing the rebar for structural bonding for 1,890 ringgit. So for the last slide that I will present, which is accelerating works and file testing. So for this slide, I will verify the foundation's load capacity with two standard tests under clause E.7. For the first one is VDA test dynamic, which is as you can see at the right side of the slide. It said we allocated two dynamic load tests at RM 3,050 ringgit each, and it has a total 7,000. And this rate covered essential equipment, real-time computer logs, and engineer certificate report. And second one for the MLT test, which is static, we budget one maintenance load test as a RM 15,000 lump sum, This covers the setup of heavy concrete bricks and hydraulic digging up to 200% design load and continuous 24 hours settlement monitoring. These structure steps ensure our piling work are fully compliant with local authorities and a standard industry practice. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mak Syakiti Yusof and I'm the track number KF230029. I can continue my part for SMM2 piling measurement process. This summary the key piling measurement under SMM2. To start, cost for manipulation and plan have been absorbed into the core piling rate. Regarding material supply, we have CT3 initial pipe costing 45,246 ringgit and cent, and CT3 in extension pipe at 20,335 ringgit and 40 cent. For 5 driving extension, we have covering a total depth at 630 meters at a rate of 12 ringgit and 95 cent per meter. Totally 8,158 ringgit and 50 cent. Finally, the cost of pie joint and trimming for 63 unit at set 1,890 ringgit. For our second slide, we look at the pie testing requirement under SMM2 process E.7. We are conducting one static maintenance load test MLT at a lump sum of 50,000 ringgit. Additionally, we have 2 high string dynamic load analysis PDA test priced at 3,500 ringgit per test for a total of 7,000 ringgit. These tests are essential to verify the structure integrity and load capacity of the installed pipe.
Moving on to the next slide, this is a taking of dimension sheet for the pie derivation. We show in the mathematical derivation, we categorize the pies into 3 types, which is pie 1 cap P1 with 30 pies, pie 2 with 32 pies, and pie cap for number PG with 80 pies. This is bring our total financial structure note to 63 pies. So down below, this is the key taking off summary, outline the material and the measurement needed. So for instance, the total driven depth is 6,030 meters. And the concrete volume for the pile caps is 6.82 cubic meters, and we will require 432.86 kilogram of the total reinforcement. The sum up the pile derivation for this section. Okay, now look at the financial aspect in the price bill of quantity summary for the bin number 1. For the piling work, as you can see, our total expense is 97,630.24, heavily driven by the supply of initial extension pile as well as the required MLT and PDA testing. So for the bin number 2, for WBLF work, as you can see, the total comes up to the 6,851.75, which cover the site activities such as excavation, pie cap, concreting, formal, and reinforcement. For conclusion, after the factoring in all the material, driven depth, and testing operation, the grand total contract sum for this work is actually for RM 104,481.99. Okay, now let's look at the financial profile and economic analysis. From the pie chart, as you can see, it is highly appears that the bin number 1 for piling works is dominant. Then the contract at the 93% compared to the 7% for bin number 2. If we dive into the specific breakdown, the grand total stands at the 104,481.99. It is worth noting that the project is heavily material dominant, where the pile supply costs alone make up 62.77% of the entire contract value. So the value at the 94,581.74. This is typically for the foundation contract, whereas the material execution hold the highest weight. Furthermore, we have allocated that 21.06% or 22,000 for quality assurance tests like MLT and PDA testing to ensure the structural safety. So lastly, the bin number 2 account for remaining the 9.56% covering the earthwork and concrete. In conclusion, this economic distribution confirms that our financial focus is highly optimized toward the structure, integrity, and preparedness.
Now, let's look at the conceptual risk and wastage assessment on this slide. On the left, we look into piling and soil dynamic based on SSM2 guideline. Fixing the driven depth at 10 meters under SMM2 helps stabilize our baseline, but we must remain cautious of soil strata variation risk under SMM2 E8. Any localized change during driving mean that quantity of baseline, not final order. Furthermore, under SSM2 E8F, the contractor bears the material waste liability, meaning all fracture concrete pile cut off must be absorbed into the fixed unit rate without extra compensation. On the right, we highlight steel measurement and a critical BQ contradiction. According to SMM2 F30, steel bar laps for T12 and T10 exclude from BQ measurement. So lapping costs are entirely absorbed within the fixed rate of RM3.29 per kilo. Finally, there is a clear disposal item contradiction where the methodology indicates a separate item under D18, but the BQ integrates disposal into the excavation rate. This requires a formal clarification before we make our final project submission. This assessment ensures we stay contractually protected while minimizing unexpected financial claim. To conclude our presentation, based on the summary, this exercise has successfully delivered several key outcomes. First, we have executed a precise quantity taking off for a total of 63 pile points across the P1, P2 and P3 configuration, fully complying with SMM2 section E and F. Second, after averaging the measurement for a fixed 10 meter driven depth, our grand total contract sum stand at 104,481.99. Third, looking at the financial profile, will number one for piling work heavily dominate the budget at 93.44%. In fact, the pile material supply alone represents 62.77% of the entire contract value, proving that the project is highly material dominant. 4. We have successfully highlighted critical contractual risks that requires close mitigation, specifically the contractor waste disposal liability under clause E.8F, the reinforcement lab exclusion under F.30, and the technical contradiction found between the 18 and the BQ rates. Finally, this overall exercise has provided invaluable hands-on exposure to standard industry practice, particularly in SMM2 compliance, JKR rate sourcing, and practical construction cost management.